I'm relatively new to Comcast, about a year and a half, and relatively new to this subject area. But I've always wanted to go to Strata to this session, because I thought, how cool is it that you have all these data people in one place all day? So, and I've never had a chance to come, but now I'm here, so I'm excited. Okay. Thanks. Okay, so data integration and governance for big data. The reason I say data integration and governance is that data governance is it's not like a nasty librarian who won't let anyone use the data, right? It's to enable analysts to integrate and understand data and not have to wrangle it quite so much. Though we heard a great instance of wrangling earlier. Oops, sorry, gotta figure this out. Okay, so I'm from Comcast. I'm a data architect there. I'm from Philadelphia, where we have terrible snow right now, so I'm really glad to be here. The mission of the project I'm going to talk about is this: to gather, organize, make sense of Comcast data, and make it universally acceptable through platform solutions and products. And I'm going to tell you about the data governance platform, which I'm the owner of. Comcast, we're huge. We have dozens of tenants who are going to use the system, tens of millions of customers, hundreds of millions of devices, millions of messages per second, tens of petabytes of storage, thousands of cores of distributed compute, big stuff. So I always like to start talks by answering the who cares question, or why should I care? This is why you should care. When we started this project, there was data chaos. So here's my motivating example. We have, for instance, a record representing an IP video player download session. And it has all kinds of cool information about what was downloaded. When I say customer account info, that really only means the customer ID, not things like, the name and what the video is and all that stuff. So we have all this interesting information. And then but any single data stream is not really very useful unless you can integrate it with others across the enterprise, and then you get to make really interesting business predictions and decisions. So suppose I want to integrate this data with customer experience data, then I have to join in the customer account. I want to integrate it with sessionized latency and buffering information, then I join on other things. The network traffic data have to join on device. So, but the problem with that is, whoops, did I go the wrong way? Sorry, I'm messing up my thing here. Page up. Here. So we have a shop of horrors because we have many customer account IDs, many device IDs, and an insanely large amount of asset IDs. Assets are movies or TV shows or something. And if you want to join with somebody else's data, you don't know, if they say customer account ID, you don't know which one they're talking about, or device ID or asset ID. So this is really a shop of horrors. So let's see if I can actually hit this correctly. Yes. So how do you fix this? Data governance to the rescue. So it can answer, these are the questions I'm going to talk about, what it answers. I want to join your data with my data, but what does your data mean anyway? And is it safe to join my data with your data? So if I join on my customer ID with your customer ID, am I going to get data that really isn't appropriate at all because your customer ID is really another customer? And I call that Franken data. Or a chimera of data. And then can I change my schema without breaking the systems of others that rely on it? So those are the things I'm going to talk about. And the problem in data science, the big problem is most of the time is spent gathering, integrating, understanding, wrangling, futzing with data. Like 70%, they say, is spent that way, and only 30% is spent actually doing analysis. We want to flip that. So that's what we're trying to do. So to begin the order from chaos, we can at least say, okay, if you're using a billing ID, that's what it means. The customer's billing ID isn't terribly informative, but at least, it's something. The XBO ID is the account ID based on the Xfinity back office. And if you're in Comcast, you know what that is. And then this other XCal account ID, which I have no idea what it is, but it's deprecated. So you can at least start documenting. And then in the device case, you can do the same thing. What do these things mean? Where do they come from? So that's the first step. Okay. But the real trick here to fixing this is Apache Avro. And I love this logo. And I am not a person who has tattoos, but if I was going to get one, it might be that one, because I think it's really cool. But anyway, so what is Avro? It's a data serialization system. It's a JSON-based schema language, which is what's important for us today. And it's also a compact serialized format. It can be serialized in binary or in JSON. It has APIs in lots of languages. And in Comcast, we use, Python, Java, C, C#, C++, and Go. And there's probably a lot more that we haven't even, Ruby probably has one. And then the goals of the Avro project are cross-language support for dynamic data access and simple but expressive schema definition and evolution. So just to do a little bit about Avro types, there are primitive types, the sort of normal things you would imagine. I'll talk about null in a minute. And then complex types, records arrays, a map, which is kind of an anonymous key value store, which we don't like it because it's anonymous, but sometimes you have to allow it. And then union types, and that can be, it's a type where it could be either this type or that type. Where that's almost always used in Avro is it can either be null or, say, a string. So it's kind of a goofy way to say optional, but that's, and then fixed, and then finally the enum type, where it can be either Larry, Moe, or Curly, but unfortunately not Shemp. I come from New Jersey, a little Three Stooges humor. So here's a real simple example, a generic application log event. So the four things that are really critical are name, type, default, and the documentation. So you can see that this is a required field that has a default. This is an optional field. Type is choice or union type, null, and string. And the doc tells you what the thing means. So we have not solved our asset ID problem yet, but we have at least corralled the asset IDs. So we represent in Avro a record that consists of all the asset IDs that you could possibly use. And one or more of these can be used to set a specific asset. So we just, it's a record and its fields are each individual asset ID, the asset content ID with the documentation of where it comes from, video on demand assets from the Cable Labs ADI specification. It's a heck of a lot better than just this sort of free-floating asset content ID. And similarly, we have documentation for all the different asset IDs. And the final one is the media GUID. The documentation is media GUID, one ID to rule them all. There's always an optimist. Needless to say, it is not one ID to rule them all, unfortunately. So, whoops. Sorry. I'm terrible at this. Okay, so I want to go on to the next question about schema evolution. If I change my schema, will it break somebody else's code? And schemas can change in unpredictable and non-backward compatible ways, so this is important. So Avro serialized data, binary serialized data anyway, is never used without its schema. And JSON serialized data is rarely used without its schema because why the heck would you? More on that later. We have empirically determined a complete set of rules for schema evolution and backward compatibility. And these are just two simple examples. you may add an optional field to your schema. You may not change the type of any field. And this empirical determining of rules was done by my colleague Gabriel Camus, who may be here, but I guess he dissed me. Okay. So that's very, you can add an optional field, that's obvious, But what's not obvious is that some chains of compatible changes produce incompatible results. So if you remove an optional string field X and then create an optional int field X, you have in that sequence of perfectly compatible changes actually created an incompatible change, in effect changing the type of the field from string to int. So this is a little bit more subtle than it sounds. But so we've got all this data and we can use it to reason, is this schema compatible with this one and then 3 schemas back? Not just the last one, but any ones. So that's an important thing to be able to do. So if we're going to use Avro schemas, we have a bunch of best practices, because you can imagine, garbage in, garbage out. You can have garbage that has a schema, right? And by the way to solve the GIGO problem is to not put garbage in. And that's what we're trying to do. So each schema is checked for compliance with our conventions. They're also reviewed and approved by at least one person. And the reason for that is that some things are easy to check programmatically, others are not. So doc comments are required to document every attribute. That can be checked easily. All attributes must have defaults. That's checked easily, but unnecessary complexity is discouraged. That is more a human review thing. And we go by the Yagni principle, which I'm told means you ain't gonna need it. So just think about it ahead of time. Are you really gonna need it? You can always add it later. Because when people have especially a heavily nested data model in their holster, they tend to go crazy with nesting. And we have one schema that's like 20 levels of nesting. It's crazy. How are you going to ever work with that? And how's a consumer going to work with that in code? So we really try to keep people from doing that. Updates are an important issue. In flight, you may want to enrich data, but you may not do that if it means changing the schema, or if it deviates from the schema and you haven't created a new schema to match it. In other words, data always has to match a schema. So yeah, I'll get to this republication of enriched data. Schemas may be evolved at will, but we check whether they're compatible changes, and we really want that to be kept to a minimum of what really needs to happen. And then most importantly, our philosophy of modular core subschema reuse. I talked about this to one of my bosses, and who was a programmer, a Java guy. He said, "Oh, this is just object-oriented programming." I said, "Okay." I'm a database person. I don't know. But so we have this GitHub repository of core subschemas, reusable subschemas. So an application running on a device, a customer account, device, all these things that are commonly used. And the idea is, if you're talking about the geolocation, if you're talking about where a device is located, whether on a street or a zip code or a state or even the marketing region, you don't need to make up your own schema for that. We have that already. And similarly for these other things. And it's so important that if you are talking about zip code and somebody else is talking about zip code, if they name it zip code and you name it postal code, why? Why would you do that? If you both name it the same thing, it's easy to join on or match. So, to recap, the benefits of Avro to the business are that it allows data integration to answer business questions that you couldn't otherwise. The benefits of data governance are standardization and all that good stuff. And there are also benefits to application developers, which I am not going to go very deeply into, but I got this from my colleague who is a super, super great Java developer. He says, Avro is awesome because Avro is a strongly typed language, so therefore all typed checking is done for you. And to consume data, you read it from the source, you apply the schema, and then boom, it's in an object in your language of choice. So in Python, it's in a dictionary. In Java, it's in an object, and the like. So no parsing. Awesome. And Bob is your uncle. And for those who aren't native English speakers, that just means thumbs up. Now you know. So I want to say a little bit about Avro in the context of data architecture in sort of a broader context. So we work on the data engineering analysis platform, analytics platform, whose acronym is pronounced DEEP. And DEEP consists of user-facing solutions and products, our own in-house analytics, and the deeper platforms, which is what I'm part of. So I like that we are deeper, and they're just deep. So the deeper architecture is like a lot of architectures that deal with streaming data. We have data, it comes into Kafka, Kafka topics. It gets transformed, or it may not get transformed. Often it gets transformed in various ways through various processes and then gets stored in the data lake. Now, and this is the part that I've been talking about, the Athene governance and security area, where we do schema creation, reviewing, lineage discovery. So why did we call it Athene? The reason is Athena is the Greek goddess of wisdom, justice, and good governance. So we had to call it something like that. But there are too many Athena projects. And right after we named this Athene, AWS came out with an Athena project for SQL on AWS. So I'm glad we didn't name it Athena. We named it Athene after the companion owl, or some may say the avatar of Athena. Athene Noctua is the little owl. And as you see on this late 5th century BC coin, isn't that cool? That is it's so gorgeous, among other things. But that is a representation of Athena's owl from late 5th century BC. We have updated it, and that's our logo, our version of Athena's owl, lean and mean. Anyway, so the key tooling components of a data governance solution. You need a metadata repository so you can answer these questions. Where can I find data about something I'm interested in? What does it mean? Data lineage. How has the data changed since it actually was ingested to where I'm viewing it now? Data validation. Does the data match the schema? And are the attributes, do they contain valid values? Security and disaster recovery are also part of this solution, but I'm not going to talk about them because they're whole different balls of wax. So we have a schema registry for data at ingest that does all the things listed here. You can search on topics and on schemas. We have schema evolution, compatibility detection, all that good stuff. We validate data against the schema throughout its journey. So on ingest, on transformation, in flight, at rest in Scratch files, at rest in long-term storage. So the idea of data lineage for data at rest is for any item in any community data store, meaning the data that we are making available to the Comcast community, and we are saying we're governing it, we're keeping it clean, we're keeping it documented, we're making it available to you to use easily. I mean, that doesn't mean sort of scratch spaces that people do on the side. But any item in a community data store, we must be able to identify the corresponding Avro schema. So this includes these sorts of data at rest. So I just wanted to show a little bit about how our platforms work together for data governance and in particular data lineage. We got good old Athene up here, the headwaters, which is the Kafka streaming data ingest, and CloudBridge and Atlantic, who do the transformations, and then we got object storage in S3 now, but it could be something else down the road. So let's see if I can do this. So say data comes streaming in, it comes to CloudBridge. CloudBridge creates an Avro file in S3, in an S3 pseudo-directory, and then tells Athene about it. So I've created this pseudo-directory, and lineage links means it came from this Kafka topic, it has this Avro schema. So all this gets sent back to Athene, where this method store. Again, if batch data that has an Avro schema comes in and say is stored in a Hive table, in this case, the Hive, we get that lineage for free because we're using Apache Atlas in the Hortonworks instantiation. And another example is say that CloudBridge takes an Avro file in S3 and makes it, takes the data and puts it in a Parquet file. Then it also says, I created the Parquet file, and this is the Avro, you can't see me when I point at the thing, can you? This is the Avro file that was used to create the Parquet file. So all this lineage is taken care of. So when you step up to Athene, you can say, you can see all these connections as follows. So this is an actual screenshot from Atlas. You probably can't read it, but that's okay. Let me just say that this is the original Kafka topic. This is an IFI process that puts it in a Hive table. This is a CloudBridge process, Spark process that puts it in a pseudo-directory. This is a Spark process that embellishes it, enriches it, creates a new so that it needs a new schema. Therefore, it's republished to Kafka. That's another Kafka topic with another schema, and then is stored in S3 pseudo-directory, or in this case, can be republished to Kinesis, which is what we use for our external partners. So this is a diagram of what I showed you in the previous slide about how the fact that that data, that lineage data gets passed back to Athene allows this kind of visualization. So, in summary, Avro to the rescue. So again, to summarize, the questions that we can answer with Avro, I want to join my data with yours. What does it mean? Is it safe? Can I change my schema without breaking other systems? Where can I find data that I'm interested in? I'm looking at this aggregated data. Where did this come from originally? And what has happened to it in the process? If I'm a producer and I send data into the Kafka topic, I might want to say, where does that end up in this system? You know, who's using it? What happened to it? So, finally, I wanted to address and share some of the challenges we had doing this and the solutions we found. So, hopefully that's readable. Creating conformant Avro schemas is not trivial for everybody. So we had detailed documentation, a sample code in a whole bunch of different languages, not for the creating of the schema, but for consuming the schema and consuming data with the schema and producing data to Kafka with the schema. And this team of reviewers is a team of reviewers, but also can help people develop their own Avro schemas. Next thing, not all agree with this. I believe, and many people believe, Avro schemas are annoying to create in the text editor. If you forget a closed bracket or a default or a quotation mark around default or something, I don't want to worry about that. So we're building a schema builder that basically sets up everything. All you have to do is put in the name of the thing and choose the type, and that's in beta, and hopefully I'll get to talk about it at some later strata. The schema review process was slow, and we trained more reviewers, but we also streamlined the processes, and we have a reviewer UI now that works with the builder UI that will soon be in beta. Not everyone, even though we, use our powers of persuasion, not everyone can or will publish data in Avro, but they usually can in JSON. So we've used Apache NiFi to convert from JSON to JSON serialized Avro and then, then we've got it in Avro and we can handle it in the rest of our stream. NiFi is really cool, by the way, if you don't know about it. It's essentially a graphical way of building flows for light transformation of data. Some developers thought that creating schemas was a drag on their productivity. Well, one thing that helped with that is a top-down mandate. But as they went along, and we helped them through the pain of learning it, they realized that it's kind of cool to have a schema when you're handling data down the road. And whereas if you don't have a schema, there were multiple instances of attributes that were the same, except one was a capital letter, one was a small letter, and just all kinds of horror stories that are fixed when you use a schema. So they've come to see that it's worth it. Nobody likes to be governed. We're all techies. We don't want to be governed. Again, the top-down mandate helps, but the analysts, of course, I'm talking about the programmers and stuff don't want to be governed, but the analysts love this idea because it makes their life so much easier. And the end users love the idea because, as I said, if you have data in serialized Avro and an Avro schema, and you apply the schema to the data, it's automatically in your language of choice. With documentation, too. And finally, this is a little beyond Avro, but finding data governance tooling to handle the metadata and lineage for all our sources, which are pretty heterogeneous and are going to get more so. We spent about 4 months looking at everything and finally went with Apache Atlas, which is open source. It's extensible. So a lot of those things you saw, like S3 pseudo directories, that does not come with. We extended Atlas to do that. It was very easy. And this is going to be, we're going to make this available to all our Comcast friends very soon. So I guess that's the end. Thank you very much for listening. Any questions? Yes.
Is this data made available to the external world in anonymized format?
Is our data? No. No, we have some partners that use our networks, our boxes, the cable. We have cable companies that use our equipment. They are able to use this stuff on their own data, but we don't make the data available. That's the family jewels, as in most companies. Anything else? Do you hate Comcast a little bit less now? What was that?
Barbara?
Yes.
Do you use the Atlas to do full end-to-end metadata lineage?
Yes.
Okay, cool.
Yes, we do. No, it works great, actually. It looked good, but you have to kick the tires and really try it out, and yeah, it's worked great for us.
So you didn't need to look at anything like the Libra or any of those other sorts of things that sit outside of...
We looked at a lot of stuff.
Okay.
And one of the things that we really wanted was open source and extensibility. And that Cloudera's Navigator is a great tool, but at the time we looked at it anyway, it wasn't extensible. So that list was really the only thing that met our criteria, and luckily it works. So, yes. Okay, anything else? Yes. Oh. It's not record by record. It's the easiest way to say it is like Kafka topic. This Kafka topic ends up in this S3 pseudo directory. So it's not. You can't trace individual data, individual rows, because that would just be plain too hard. If we need to, someday maybe we will, but so far not. Okay, thank you very much.